is going to displace massive resistance with a smaller object. Here's a nickel. I'm going to put that right there. Weighs 5 grams, so you know my scale works. A US dollar nickel. Now, we're going to put that on there. We're going to go ahead and hit tear. Tear it out here. There we go. 0 grams. Here's the weight of that. About 155 grams. Technically, it's about 156, but there's a lot of dings in it. And then, let's go ahead and weigh our little mass here. Yeah, it's about 6 grams. Okay. You can obviously tell that this object is way bigger than that object, right? Totally 2 different sizes. Now you're going to look over here. This is Newton's cradle. These are the measurements of the distance of acceleration into an impact with Newton's cradle. What I'm going to do here, I'm going to go ahead and just put that right there. Okay. Now, to prove this is kind of level, I'm going to go ahead and just set that right there and doesn't really roll, right? Let's pull my sundial out. Doesn't really roll around. Oh, look at that. All right, looks like I'm going to be fighting gravity in this explanation too. Looks like I'm fighting gravity. So we know gravity is pushing up against this, all right? Now, each one of these little balls are the same as this. If you look really closely, that ball is the same as that ball, as that is that. And what I did is I bought like 2 or 3, actually I bought 4 of these Newton's cradles here and demonstrated this. What I did is I took this mass right here, and grab that right there. See how that spring is right there? And what this is gonna do is I'm gonna pull it back into this catapult. See the distance right there? I'm gonna accelerate this mass into an impact into Newton's cradle. This ball is gonna come over and hit that ball, and that ball is gonna go down there, okay? This is gonna prove kind of what we're experiencing in space right now with the rocket, I think the DART rocket. They're gonna take a really small object like this and hit a really big object and displace it. So imagine this is the asteroid, this is gonna be the satellite, and the satellite hitting the asteroid. Let's see what we got here. Now you're gonna probably be like, well, the asteroid's moving through space, right? So that's why gravity's pushing up against this. So we know that gravity's, its vector and velocity is in that direction. No matter what I do, it'll do that, right? I stop and I push it that way, it's gonna roll back this way. So we know the vector and velocity of this object is in this direction. And this vector and velocity is in that direction. Let's see what happens here. Go ahead and grab that. And hold on. 1. So I'm pulling back. 2, 3. Look at that. It sure displaced it, didn't it? Ta-da! That's how that rocket's gonna hit that asteroid. That rocket is gonna blast into the asteroid and knock the asteroid off its vector and velocity in space.